More work with parent functions. Notice that f of x here is not like what we've seen before with quadratics or absolute values or cube roots, cubed, square roots, any of that. It's just 4 points connected. We are going to take the parent function, which is listed on each of these graphs, and do the operation or the transformation that is posted. So for the first one, f of x is already on my paper, and I'm going to shift, this plus 3 here tells me that I'm going to shift all of those points up 3. Connect my dots, and I'm done. The next one, the x plus 2, is on the inside, which tells me that I'm going to move it left 2. So I'm just going to take all the points that I see and move them left 2. The y does not change. Doesn't stretch, doesn't shrink. For the third one, I have a negative on the outside, which tells me that I'm going to flip it over the x-axis. So just take all of your y coordinates and make them the opposite. So for the first one, I have a y coordinate of -2, so now it's just going to be +2. I have a y coordinate of +2, so -2, -2, and 0 is going to stay the same. Kind of looks like a fish. Number 4, x minus 1. The 1 is on the inside. I'm going to shift right by 1. So all of my points are going to stay the same y, but they're all going to shift 1. Notice that the shape looks the same. Going back to geometry, it's identical or it's congruent. It's just in a different location. For the third one, the 2 on the outside is going to stretch the function vertically. So all of my y coordinates are going to double. So I have -2 here, so it's now going to become -4. I have 2 here, so it's going to become +4, +4. 0 is going to stay the same. For the third one, the -4 is on the outside, so it's going to move down 4. Number 7, the 1/2 on the outside is going to compress this function vertically. So all of the y coordinates are going to be reduced by 1/2. So if I have a -2, it's now going to become -1. +2 becomes 1, it becomes 1, 0 stays the same. Number 8, the negative is on the inside, so it's going to flip over the y-axis. So +4 becomes -4, -4 becomes +4, the y stay the same, 0 stays the same, and +2 becomes -2. So I kind of did that in a backwards order, but I did pay attention to all the points. Number 9, f of 2 of x, the 2 is on the inside, so it does the opposite of what I think it should do. So 2, I think of as a big number, I think that it would grow, but it's actually going to shrink, so it's going to compress horizontally. So all of my x coordinates are going to be reduced by 1/2. The y coordinates stay the same. So I have -4 becomes -2. 0 stays the same. 2 becomes 1. And an x coordinate of 4 becomes 2. So it is compressed horizontally. Of course, they're not always going to be as easy as the first page. There's going to be multiple transformations happening to one function. Remember that we have to think about the order that we do them in, and that stretches and compressions and reflections should come first. Translations, which means moving it left, right, or up or down, should be the last thing. Kind of like PEMDAS. A good idea when anytime you have a parent function is to keep a list of the points that you're given. So in this f of x function, we have the point -4 is 0, we have the point 0,4, and we have the point 2, -2. If we can just think of those points and apply the transformations, sometimes it's a little bit easier. It's also a good idea to write down what the transformations are doing before you change all of the points. For the first one, we have 1/2 f of negative x plus 3. The 1/2 on the outside is going to compress vertically by a factor 1/2. So I'm going to take my y-coordinate and divide it by 2. The negative on the inside flips it over the y. And the plus 3 on the end moves it up 3. Now let's graph our points. My first point is -4, 0. Compressing it vertically, I divide the y by 1/2. Stays the same. So it's -4, 0. Flipping it over the y-axis, it now becomes 4, 0. Then I'm going to move it up 3, so it ends at the point 4, 3. My next point, 0, 4. I'm going to divide the y by 2, so it now becomes 0, 2. I'm going to flip it over the y, so that point doesn't change. Then I'm going to move it up 3, so it becomes 0, 5. My last point, 2, -2, I'm going to divide the y by 1/2, or actually multiply by 1/2, so it's 2 divided by, or -2 divided by 2, which is -1. So I have 2, -1, but I'm going to flip it over the y, so it becomes -2, -1, and then I'm going to move it up 3, so it becomes -2, 2. I can always check and make sure it kind of has the same pattern going on, or it should look somewhat similar. Number 2, the negative on the outside is going to reflect it over the x-axis. The plus 4 should be my last thing, and that's going to move it up 4. And the 2 on the inside does the opposite of what I think it should do. I would think 2 would make something grow, but instead it's going to compress this graph horizontally. So again, looking at my points, let's start with -4, 0. Reflecting it over the x, it's going to stay the same. Compress horizontally by a factor of 2, so it now becomes -2, 0. I'm going to move it up 4, -2, 4. My next point, 0, 4, reflects over the x, so it becomes 0, -4. I'm going to compress it horizontally, so that doesn't change. Then I'm going to move it up 4, so it's at 0, 0. Our third point is 2, -2. First thing, I'm going to reflect it over the x, so it now becomes 2, +2. I'm going to compress it horizontally, so 2, 2 becomes 1, 2, and then I'm going to move it up 4, so it becomes 1, 6. Number 3, the 2 on the outside is going to be a vertical stretch. So all my y-coordinates are going to be multiplied by 2. I have a -3 on the outside, which tells me that I'm going to move my graph down 3, and that should happen last. And I actually have to pay close attention to the inside. I really need to factor out that negative. Otherwise, I'll be moving my graph the wrong way. So that should always happen. That negative now on the outside of the inside tells me that I'm going to flip my graph over the y-axis, and I'm really going to shift my graph left 1. Whereas by looking at it in the beginning, I might think that I should shift it right. Okay, so this is a good example. You always have to factor on the inside. Pull out a GCF, which is usually a negative sign. Now I'm ready to graph. My first point, -4, 0. Need to multiply has a vertical stretch of 2, so my y gets multiplied by 2, stays the same, -4, 0. Flip over the y, so it becomes 4, 0. I'm going to multiply or move it left 1, -3, 0, and down 3 becomes 3, -3. My second point, 0, 4. Vertical stretch by 2, so it becomes 0, 8. Flip it over the y, nothing changes. Move it left 1, so -1, 8, and down 3, -1, 5. My third point, 2, negative 2. Vertical stretch by 2, so it becomes 2, negative 4. Flip it over the y, so it becomes negative 2, negative 4. Move it left 1, negative 3, negative 4, and then down. And down 3, so it becomes negative 3, negative 7. Connect your dots, and you're good to go. Now is a good time for you to stop, hit pause, give the next 3 examples a try. Do it in pencil so that if you make any mistakes, you can go back. Take your time as you are doing it. Notice that I remembered to write the 4 points that made up my parent function. Then in number 4, I factored out the 2 on the inside and wrote the transformations that were happening. My first point, negative 5, 2, has a vertical stretch of 2, so it should become negative 5, 4. Then it has a horizontal compression, so it should become negative 2.5, 4. Then I'm going to move it left 1, so it becomes negative 3.5, 4. My next point, negative 2, negative 4, vertical stretch, so 2, negative 8, horizontal compression, negative 1, negative 8. Then move it left, so negative 2, negative 8. My third point, 0, 0, vertical stretch, nothing happens. Horizontal compression, nothing happens. Move it left 1, so I have negative 1, 0. My fourth point, 4, negative 5, vertical stretch, so 4, negative 10, horizontal compression, 2, negative 10, move it left 1, 1, negative 10. Connect them in the order, done. We need to flip over the x and the y and then move it up 4 for number 5. My first point, negative 5, negative 5, 2, flip it over the x, so it becomes negative 5, negative 2, flip it over the y, so it becomes positive 5, negative 2, then move it up 4, positive 5, 2. My next point, negative 2, negative 4, flip it over the x, so it becomes negative 2, positive 4, flip it over the y, so it becomes 2, 4, move it up 4, becomes 2, 8. 0, 0, flip it over the x and the y, nothing happens, move it up 4, 0, 4. 4, negative 5, flip it over the x, becomes 4, positive 5, flip it over the y, becomes negative 4, positive 5, move it up 4, negative 4, 9. Connect them in the order that you did it. There we go. The last one is a good one. Don't forget to factor out the inside. I can take out a negative 1/2, then I am left with x minus 3, on the outside minus 2. This tells me, the negative tells me that I'm going to flip over the y. The 1/2 tells me that I am going to stretch horizontally, so multiply all my x coordinates by 2. The minus 3 on the inside means I'm going to move right 3, and then the minus 2 on the end tells me I'm going to move down 2. My first point, negative 5, 2. Flip over the y, so 5, 2, stretch horizontally, 10, 2, right 3, 13, 2, down 2, 13, 0. Don't worry that it's off the graph. My next point, negative 2, negative 4. Flip over the y, so 2, negative 4, stretch horizontally, 4, negative 4, move it right 3, 7, negative 4, down 2, 7, negative 6. Third point, 0, 0, flip, nothing happens, stretch, nothing happens, right 3, so 3, 0, down 2, 3, negative 2. My last point, 4, negative 5, flip over the y, So it becomes -4, -5, stretch horizontally, -8, -5, right 3, -5, -5, down 2, -5, -7. Connect those dots. There we go. When you go to do the homework, take your time, make sure you list out your points, write down all the transformations that are happening. Don't forget to factor what's on the inside.